Inductor current and voltage. An inductor has inductance 0.43 henries and carries an electric current in the direction shown on the diagram down here. The current varies with time at a constant rate. The electric potential difference between points B and A is 0.78 volts. Which point, A or B, has the higher electric potential? B, is the current increasing or decreasing? Please explain. And if the current at time equals 0 is 1.8 amps, what is the current at t equals 1.5 seconds? Which point, A or B, has the higher electric potential? Explain. The electric potential difference for an inductor is defined as the voltage at the conventional current entrance to the inductor, which in this case is point B, minus the voltage at the exit. So that's VB minus VA. The potential difference is 0.78 volts, so we do some not terribly complex math here. 0.78 is certainly greater than 0. VB minus VA is greater than 0. VB is greater than VA. Is the current increasing or decreasing? Explain. We have our expression here for the potential difference. And in the presentation, it was written VA minus VB. Why? Because the current was going this way. It's always the entrance minus the exit. Do a little algebra, and we find that di dt has to be positive because VB minus VA is positive, L is positive, therefore the current is increasing. If the current at t equals 0 seconds is 1.8 amps, what is the current at 1.5 seconds? Well, we have our equation here, di dt equals VB minus VA over L. Since the current is increasing at a constant rate, we'll go ahead and replace the differential with a delta form here. We then multiply through by delta t. We plug in our values, okay, right there. And we were told VB minus VA is 0.78 volts. Here's the inductance. Here's the time. So in, let's see, 1.5 seconds, the current will change by 2.7 amps. That's not what was asked for, though. We want to know the current at that time. So we have to say it's equal to the current in the beginning at time equals 0 plus delta I, 1.8 plus 2.7, 4.5 amps, showing that the current increased, which is consistent with the first two parts of this problem.